Alright, so here's where we tie it all together. How do we use the unit circle? Why do we care about the unit circle besides that it's amazing and beautiful and mathematical in its own way? Well, we want to be able to use it, right? So it is a useful tool for us to quickly evaluate and understand trig functions. It's going to relate to graphing of trig functions. It's really relates to everything. It's our right triangle trig as well. So let's just jump right into it. How does it relate? Well, first I'm just going to draw this triangle again, but instead of saying that that's the 30, 60, 90 triangle, which it is, right, I'm just going to generically label it, and we know that this is our theta, because theta, when we draw an angle in standard position, always has our initial side on the positive side of the x-axis and the terminal side on the other side of the angle, I guess. And so with the unit circle, we know that the radius is 1, and we know in terms of coordinate points, right, this is some point xy, where this is x, and this is y. So now, if I think about, well, how does sine relate to this angle theta? Well, sine is opposite over hypotenuse. So I could say the sine of theta is y over 1. But what is anything divided by 1? It's just itself. So really, the sine of theta is the y-coordinate, right? So everywhere on the unit circle, and this only applies when we're dealing with the unit circle, the y-coordinate is representing the sine value at that angle. Think about what that means, right? The value of sine at any angle on the unit circle is the y-coordinate. Remember, that's representing the ratio of sides of a triangle. So then, what about cosine? Well, cosine is adjacent over hypotenuse, but the hypotenuse is 1. So cosine is the x-coordinate. And then tangent is opposite over adjacent. So it's y over x. Now, what about the reciprocal functions, cosecant, secant, and cotangent? Well, those are the reciprocals of these, right? So if we put this all together, sine of theta is the y-coordinate, cosine of theta is the x-coordinate, tangent of theta is y-coordinate over x-coordinate, cosecant of theta is 1 over the y-coordinate, secant of theta is 1 over the x-coordinate, cotangent of theta is the x-coordinate over the y-coordinate, because these are reciprocals. Boom. That's how they relate. How is that helpful? Great question. I'm glad you asked. You're probably like, what is going on? Alright, this is cool, but I still don't totally get it. Okay, so now let's evaluate trig functions. Now remember, we learned how to do this on the calculator, but what if we aren't allowed to use a calculator, or if we don't have a calculator, or if we just want to be a little bit more efficient, because it's not always efficient typing things into the calculator, right? So if I want to evaluate the sine of 5 pi 6th, and I know my unit circle, I can think to myself, okay, well, where is 5 pi 6th? 5 pi 6th is right here. How does sine relate to this angle? Sine is the y-coordinate. The y-coordinate is 1/2. So boom, the sine of 5 pi 6th is 1/2. Right? See how easy that was? No work involved. Just had to think and understand. Cosine of 5 pi 4th. What is that? Alright, so let's look back at our unit circle. Where's 5 pi 4ths? Good question. Glad you asked. Third quadrant. Cosine. How does cosine relate? Cosine is the x-coordinate. The x-coordinate is negative root 2 over 2. So the cosine of 5 pi 4ths is negative root 2 over 2. And now I do want to just back up one quick second. If we go back to our calculator, and I make sure I'm in radians, I am, good. So if I type in the sine of 5 pi divided by 6, I get 1/2, right? So we could have done that on the calculator, but again, if we know the unit circle, that was just much easier to say, oh, sine of 5 pi 6 is 1/2, right? Okay, how about cotangent of 5 pi 3rds? Good question. So first let's find 5 pi 3rds. 5 pi 3rds is going to be in the 4th quadrant, right? So that's like that angle, okay? But cotangent, well, what did we say cotangent? How does that relate? That's the x-coordinate divided by the y-coordinate. Okay, so the x-coordinate is 1/2, and the y-coordinate is negative root 3 over 2. Oh man, you're telling me I gotta do division of fractions? So if I have 1/2 over negative root 3 over 2, I don't like my answer like that. So remember, when we have division of fractions, we want to multiply by the reciprocal of the denominator. So I'm going to multiply by 2 over root 3 in the numerator and denominator, because algebraically that's what I have to do. Those two cancel. The negative is still here, so I'm left with negative 1 over root 3. So we could write negative 1 over root 3, or if that's rationalized, negative root 3 over 3. Either of those would be correct. Alright, I want you to try and do these three. So pause the video, try and do those. Use the unit circle. Don't use your calculator. Use the unit circle. You can do it. It's great. This is why the unit circle is amazing. Pause the video, unpause when you're ready to check. Alright, so hopefully you got these answers. Cosecant of 315 degrees is negative root 2. Secant of 60 degrees is 2. Tangent of 150 degrees is negative root 3 over 3. If you are a little bit confused, let's go through those real quick though. So first for the 315 degrees. Okay, so 315 degrees right here. Cosecant, how does cosecant relate? Cosecant is the reciprocal of the y value. Remember though, so here, I'll show you the work that I did, but the work that I did is not necessary. I'm just showing. So the reciprocal of the y value would be 1 over negative root 2 over 2. Multiply the top and the bottom by the reciprocal of the denominator, negative 2 over root 2. Those cancel. I'm left with negative 2 over root 2, but if I rationalize that, this becomes just negative root 2. I do want to point out though, remember when we look at these values, like the root 2 over 2, this is a rationalized value. Right? Remember that when we see root 2 over 2 here, whoops, let me do that. When we see root 2 over 2 right here, that was actually 1 over root 2. And so the reciprocal of 1 over root 2 is just root 2. Something to keep in mind, it makes things a little bit easier. Okay, and then the tangent. So tangent of 150, tangent is the y-coordinate divided by the x-coordinate. Notice that this is the exact same work that we did up here for the cotangent of 5 pi over 3. So I didn't show the work again because I know what the answer is. A couple of hints with tangent and cotangent. With all of this, you will notice things are very repetitive, right? So you start to see, okay, with tangent and cotangent, a lot of times I'm either going to get 1/2 over root 3 over 2 or root 3 over 2 over 1/2. And depending on where the root ends up, I'm either going to rationalize it or it's just going to be root 3 on the top. If you're confused on what I'm saying with that right now, that's okay. I'm just trying to, give you some hints on how to make some of the simplification a little bit easier, but not crucially important things that you have to understand right now. Okay, next thing. Now we're going to do, again, similar to what we did before with the calculator, but we're going to do this with the unit circle. So we're going to find the angle theta in both degrees and radians. We still have restrictions on theta, but notice that the restrictions have gotten a little bit bigger. So remember when we used our calculator, the restriction was 0 to 90 degrees or 0 to pi halves. Now the restriction is 0 to 2 pi in radians, not including the 2 pi, but including the 0. And then 0 to 360, not including the 360 degrees, but including the 0 degrees. So why do we need the restrictions on theta, and how many potential answers will there be from the restrictions for each problem? Good questions, I'm glad you asked. So we need the restrictions for the same reason we had the restrictions before, otherwise there would be an infinite amount of answers, right? Because of coterminal angles. Now, one thing I want to point out with that is, notice, and I emphasize this, we are not including the 2 pi, but we are including the 0. Why is that? Good question. We are including the 0, but not the 2 pi, because those are coterminal angles. So we want to be able to include everything, but not the same angle. We don't want any repetition of angles. We don't want to include coterminal angles. So the same is true with the 0 and the 360. How many potential answers will there be from the restrictions for each problem? That's a good question as well, and that we can see better if we look at the unit circle. So I'm going to erase this just so that's not in our way. Notice, like, let's think about sine, right? Sine is the y-coordinates. Well, if I look at the y-coordinates, just pick any specific reference angle. So I'm going to go with the 30-degree reference angle. Here's the y-coordinate, here's the y-coordinate, here's the y-coordinate, and here's the y-coordinate. So those are all of the y-coordinates when there is a 30-degree reference angle. What do I notice about them? Well, there's pairs, right? Both of these are 1/2. Both of these are negative 1/2. So, when I think about how many potential answers will there be from the restrictions for each problem, there's probably 2. Not always. And we'll see some cases where it's not true. But there's usually going to be 2. And now when I say 2, that would be 2 in radians and 2 in degrees. So for these problems, it'll actually be 4 total answers. Alright, that's a lot of me talking. Let's actually do this. So sine of theta equals negative root 3 over 2. How do we do that? Well, hopefully it's pretty straightforward. We just go to our unit circle and we look and see where is the y-coordinate, negative root 3 over 2. And so again, I'm going to erase these just so we're not distracted by that. And I'm looking for the y-coordinate, negative root 3 over 2, negative root 3 over 2. What are those angles? That is 4 pi thirds and 5 pi thirds, and 240 degrees and 300 degrees. So here I'm going to say theta equals 4 pi thirds and 5 pi thirds, or theta equals 240 degrees and 300 degrees. That's it. Let's do cotangent. So cotangent of theta equals negative 1. How do I do that? Well, I have to think, how does cotangent relate to the coordinates on the unit circle? Good question. Cotangent, remember, is x divided by y. So now I have to think to myself, well, if I divide two numbers and I get negative 1, what has to be true about those two numbers? Or a better question, to help me really understand this, if I divide two numbers and I get positive 1, what has to be true about those two numbers? They have to be the same. So if I get negative 1, if I divide two numbers and I get negative 1, they have to be the same value, but one of them needs to be positive and one of them needs to be negative. So what I'm looking for is, where do I have an x and a y coordinate that are exactly the same except for opposite signs? And I see that here, and I see that here. Here they're the same, but they're exactly the same. They're both positive. Here they're the same, but they're exactly the same. They're both negative. So if I was to divide here, I would end up with a positive 1. If I divide here, I get a positive 1. So where are these answers? This is at 3 pi fourths and 135 degrees, or 7 pi fourths and 315 degrees. Alright, I want you to try the last two. Pause the video, try and figure those out. Unpause when you're ready to check. One hint, think about, what does it mean if I divide two numbers and I get undefined? What had to be true? What would I divide by that would make something undefined? Alright, pause the video, unpause when you're ready to check. Alright, so hopefully you ended up with, for secant of theta equals 2, theta is pi thirds and 5 pi thirds, or 60 degrees and 300 degrees. And for cosecant of theta, it's undefined. Theta is 0, or pi radians, and theta is 0 degrees, or 180 degrees. Now for this, did anyone put 2 pi and 360 degrees? Because remember, those are not included in our restriction, right? We are including the zeros, not including the 2 pi and the 360. Here I'm showing a little bit of explanation of what I was thinking. So if secant of theta is 2, then cosine of theta is 1/2. Because these are reciprocal, so I'm looking at where is the x-coordinate, 1/2. And here, if cosecant is undefined, then sine of theta is 0, because dividing by 0 gives me undefined.